Okay, in this next section here, we are going to look at applying congruence and triangles. This whole unit is about proving triangles are congruent. So this particular section will really set up the basics behind what does that actually mean. So let's start here at this few blanks here to fill in. All right, the first blank I'm going to have you fill in is the phrase congruent figures. Congruent figures. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. So this is corresponding parts. So every item in one figure is congruent to its corresponding parts in the other figure. In congruent polygons, this means that corresponding sides and the corresponding angles are congruent. So consider a triangle. You have three sets of sides and three sets of angles. So the corresponding sides in one figure must be congruent to the corresponding sides in the other, and the same for angles in order for the whole shape to be congruent. All right, we have a theorem here called third angles theorem. And what the third angles theorem says, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So let's just put some numbers on here and let me prove it to you with the triangle sum theorem where all three numbers add up to 180. So let's just make these numbers real easy to work out in our head. Let's say that this is a, 60-degree angle. And so since this one has the same amount of arcs on it, it's also a 60-degree angle. Let's say that this is a 40-degree angle, which makes D also 40 because it's congruent. Well, mathematically, the third angle here, all three angles in this triangle have to add up to 180. So mathematically, that third angle has to be 80. And if I do the math over here, I'm going to get the same number. So what it's saying is we don't really have to go through the math every time. If we've got a scenario where two angles out of one are the same as two out of another triangle, well, the math will always work out that the third one will also be the same amount. And so we call that the third angles theorem. That way we don't have to go through and check that. So we'll come back and use that here in a minute. Okay, this next group of theorems, we have this same reflexive, symmetric, and transitive property that applies also to triangles. So remember, for reflexive, it's the same name back again. So triangle ABC is congruent to itself, triangle ABC. Remember, on symmetric, I think of it as the switching property. If ABC is congruent to triangle DEF, then triangle DEF is congruent to ABC. And then transitive, it's kind of like saying if A equals B and B equals C, then A equals C. So we've got the same idea along with triangle names. Okay, this example here at the bottom, we are going to use properties of congruent figures. So in the diagram, this is just a polygon. Polygon ABCDE is congruent to polygon FGHIJ. Find the value of X and find the value of Y. Okay, so I want to point you back up to the definition. If we have a congruent figure, then its corresponding parts are equal. So what that means is, because we are told right here that the figures are congruent, I can go in order of the name of the polygons and align things together. So what I mean by that is, since A comes first in the diagram, angle A is going to be congruent with angle F because it also comes first in the name. I think I said diagram, in the name. Another item is IJ is a segment. Okay, here's IJ. Because it is the last two letters of the name, it's going to be congruent to DE, the last two letters of the other name. So I could say here that this segment is congruent to this one. The only reason we can do this is because the figures are congruent. If I was not provided that, I couldn't link up things in order of the name. So finding the value of X. So X is located right here along JF. So let me erase some of this. Oops, it didn't really erase. So JF are the first and last letters. It's congruent to AE, the first and last letters. So I don't always want to go by the way it is situated because sometimes the triangle or the polygons are rotations of each other. So it's hard to necessarily tell that. So I know that, I'm going to write a couple things down here. I know that segment AE is congruent to segment FJ because of the, I'm told that they are congruent in general. So I can set those two expressions equal to each other. So 10 equals 3x plus 4. And then that's going to, of course, allow me to solve for x. Take away 4 from both sides gives me a 6. Divide by 3, looks like I get 2, okay? All right, find the value of y. So let's look at y on the diagram. So y is located at angle I. So angle I is congruent to angle D. So angle I is going to be congruent to angle D. So I know that this angle is congruent to this one. So I can say that 8y minus 9 is equal to 47. So we have just situated or linked up the corresponding parts. Okay, and that's one of the basic definitions of congruent figures is their corresponding parts are equal. Add over 9, it'd be a 56. Divide by 8 gives me a 7. Okay. Congruent figures have corresponding parts that are equal, so we are able to link together the pieces that are the same. Okay, let's go on to number 2. We are going to write a congruent statement, so I'm going to define that for you, and we are going to list corresponding angles and corresponding sides. So I'm going to first start with the angles and sides. Okay, so let's start with angles. All right, so I'm going to go off of the arcs. I see a single arc here and a single arc here. So when I name this first single arc, I need to name the vertex in the middle. So that's angle DAC. That's this angle here. This angle here that C is on, it's going to be named BCA. So angle DAC is congruent to angle BCA. Now, as long as C is in the middle, I could have said ACB. Okay, double arc angles. So this one right here is ACD, angle ACD, or I could have called it DCA, is congruent to the other double arcs. I'll call that BAC. Okay, I can also say that this angle D is equal to this angle B by the third angles theorem. So I can call it angle D because there's no other angle attached to D, or I could call it ADC, either way. So I'll just say angle D is congruent to angle B, and in parentheses I'm going to write third angles theorem. I'll just abbreviate theorem. Okay, let's do sides. Single tick mark, single tick mark. So AD is congruent to BC. Segment AD is congruent to segment BC. Double tick marks. DC, AB. So segment DC is congruent to segment AB. Okay, remember you can switch the order of your segment names. I'm also going to put a triple mark right here on AC. So do you see how AC is part of this triangle? And then AC is also, let me get a different color here, is also part of this triangle. So it's really the same segment in both triangles. So I'm going to write here a segment AC, so I'm looking at the AC that attaches to the left triangle, is congruent to AC out of the right triangle. This is our reflexive property of congruence. This is why we have reflexive property. So let's write that out. We will see that a lot this unit. Reflexive property of congruence. So whenever there's not a marking provided, I need to write down how I came up with that. So that's why I wrote that down for third angles theorem and reflexive property. Okay, write a congruent statement. A congruent statement is in the form of a triangle. These actually are all congruent statement, but we're going to write a triangle congruent statement. So I'm going to start by naming the first triangle. So I'm just going to start with, I'm going to name the left triangle. I'm just going to start with A, and then I'll move over to D and then pick up C. So triangle ADC is congruent to triangle. Now I need to name the other triangle in a corresponding order. So I'm going to look at segment AD. So segment AD was congruent to segment BC. So I need to start with BC and then move my way up to A, because everything has to match up. So like, let's just make sure that that worked that way. I have got A out to D over to C. Oh, wait a minute. I just noticed I have to go the other way around, don't I? So I have to go, even though BC matches up with AD, I need to make sure AC matches up in the name. And let me kind of show you this. See how AC are the first and last letters, but AC are the second and third. So we can't have that. So this is why it's good to check it. All right, so instead of going B into C, I'm going to start with C, go out to B, and up to A. So let's make sure stuff matches. I've got segment AD, is it congruent to CB? AD and CB, yes. How about DC and BA? Are those congruent? So DC has 2 marks, BA also has 2 marks. And then I've got AC, and there's AC. All right, so this is my congruent statement. So I'm going to write here congruent statement. Okay. All right. Well, what I'd like you to do is try 3 and 4. I want you to pause the video, and I would like you're finding the value of X. You can find Y also, but let's just do X in number 3. And in number 4, I would like you to also find the value of X. So go ahead and pause while you work on this. Okay. Just focusing on X. I see X is along a segment named QR. So QR is right here. Because the polygons are congruent, it's congruent to FG. So segment QR is congruent to segment FG. So I'm going to actually put tick marks on there. So QR and FG are congruent. So my equation is going to be 2x minus 4 equals 12. From there, then, you can solve it. That would be 16. X is 8. Okay, number 4. All right, I see that this angle is congruent to this one. I see this angle has double arcs. It's equal to this one. So I need to double check and make sure, is this angle here truly congruent to this one? And it is, because of that third angles theorem. So I am able to set those equal to each other. And I'm going to put in here third angles theorem. Because you can't just automatically assume they're equal. We have to have a reason why. Let's distribute. This is one way to do it. You could divide both sides by 5, but you can also distribute. Take away, oh, wait a minute. I just realized this is a plus sign and I wrote a minus. So that should be plus, that should be plus. Now I can take away 25. That would give me 30, and then I would get a 2 here. Okay, well that sets up our second section. One more thing I want to remind you of is, again, congruent. If figures are truly congruent, all their pieces are equal. So that means when we're talking about triangles, the 3 sides in one triangle are equal to the 3 sides in the other, and same with corresponding angles. Okay, that wraps up this lesson.